The term 3D printing encompasses several manufacturing technologies that build parts layer by layer. Each varies in the way they form plastic and metal parts and can differ in material selection, surface finish, durability, and manufacturing speed and cost. In today's video, we are going to show you different types of 3D printing. Without further ado, let's begin. Stereolithography, SLA. It is the world's first 3D printing innovation introduced by Chuck Hull in 1986. It works by a 3D printing technique called vat polymerization, where a material called a photopolymer gum is specifically restored by a light source. Stereolithography is the first modern 3D printing measure. SLA printers dominate at delivering elevated levels of detail, smooth surface completions, and tight resistance. The quality surface completions on SLA parts look decent. It's generally utilized in the clinical business, and basic applications incorporate anatomical models and microfluidics. In particular, an SLA printer utilizes mirrors, called galvanometers. One is situated on the X pivot, the other on the Y hub. These point to the purpose of a laser pillar across the tank of gum, specifically relieving and setting a cross part of the item in the forming zone, developing it layer by layer. SLA is a quick prototyping measure where exactness and accuracy are taken seriously. It can create objects from 3D CAD information in only a couple of hours. This is 3D printing measures its fine subtleties and precision by changing over fluid photopolymers, a unique kind of plastic, into strong 3D items, each layer in turn. The plastic is initially warmed to transform it into a semi-fluid structure, and afterward, it solidifies on contact. The printer develops every one of these layers utilizing a bright laser coordinated by X and Y filtering mirrors. A recoater sharp edge also gets across the surface right before the next step to guarantee each thin layer of gum spreads equitably across the article. The print cycle proceeds thusly, building 3D items from the base up. When finished, the 3D part will typically have a synthetic shower to eliminate an overabundance. It's additionally basic practice to post-fix the article in a bright broiler. This makes the product more grounded and more steady. SLA printing has gotten support for many assortments of ventures. A portion of these incorporate auto, clinical, aviation, diversion, and furthermore to make different customer items. Printers that are used are Viper's, Projet's, and iPro's 3D printers fabricated by 3D Systems. Specific laser sintering. SLS softens together nylon-based powders into strong plastic. Since specific laser sintering parts are produced using genuine thermoplastic material, they are tough, reasonable for utilitarian testing, and can uphold living pivots and snap fits. In contrast with SL, parts are more grounded, yet have harsher surface completions. SLS doesn't need help structures, so the entire form stage can be used to settle various parts into a solitary form, making it appropriate for part amounts higher than other 3D printing measures. Numerous SLS parts are utilized to model plans that will one day be in fusion shape. It utilizes a 3D printing measure called power bed fusion. A container of thermoplastic powder, nylon 6, nylon 11, nylon 12, is warmed simply beneath its liquefying point. At that point, a recoating or wiper sharp edge stores a meager layer of the powder, generally 0.1 mm thick, onto the forming stage. A laser bar starts examining the surface, where it specifically sinters the powder, which means it hardens a cross part of the article. Likewise, with SLA, the laser is centered around an area by a couple of galvos. Polyjet. Polyjet is another plastic 3D printing measure, yet there's a curve. It can create various parts with different properties, for example, tones and materials. Architects can use the innovation for prototyping elastomeric or overmolded parts. Fused Deposition Modeling, aka Fused Filament Fabrication. An FDM printer works by expelling a plastic fiber layer by layer onto the forming stage. It's a savvy and fast strategy for delivering actual models. There are a few occasions when FDM can be utilized for practical testing, however, the innovation is restricted because of parts having generally harsh surface completes and lacking strength. It is a 3D printing innovation that utilizes a cycle called material extrusion. Material extrusion gadgets are accessible and reasonable of all. They work by a cycle where a spool of a fiber of strong thermoplastic material, PLA, ABS, PET, is stacked into the 3D printer. It is then pushed by an engine through a warm spout where it liquefies. The printer's expulsion head, at that point, moves along explicit directions, keeping the 3D printing material on a form stage where the printer fiber cools and cements, shaping a strong item. When the layer is finished, the printer sets out another layer until the item is complete. Basic applications for FDM incorporate electrical lodgings, structure and fit testings, jigs and fixtures, and investment casting patterns. The best part about FDM is that it offers the best surface completion. In addition to full tone alongside the reality, there are different materials accessible for its utilization. Digital light process. DLP has quicker print times than SLA in light of the fact that each layer is uncovered at the same time, rather than following the cross part of a zone with the purpose of a laser. Regular applications for SLA and DLP are infusion-shaped type polymer models, adornments, dental applications, and amplifiers. They have fine element subtleties and smooth surface completion. They are restricted by being weak, in this way unsatisfactory for use as mechanical parts. Multi-jet fusion. Multi-jet fusion assembles utilitarian parts from nylon powder. As opposed to utilizing a laser to center the powder, MGF utilizes an inkjet cluster to apply melding specialists to the bed of nylon powder. At that point, a warming component disregards the bed to combine each layer. This outcome in more predictable mechanical properties contrasted with SLS just as improved surface completion. Another advantage of the MGF cycle is the quickened fabricate time, which prompts lower creation costs. MJ differs from other types of 3D printing technologies that deposit, sinter, or cure-built material with point-wise deposition. Instead, the print head jets hundreds of droplets of photopolymer and cures or solidifies them using UV light. Once a layer is deposited and cured, the build platform lowers by one layer thickness, and the process is repeated until a 3D object is built. Another difference from 3D printing technologies is instead of using a single point to follow a path that outlines the cross-sectional layer, MG machines deposit build material in a fast, line-wise manner. Articles made with MJ need help during printing and are printed all the while during the form cycle with a dissolvable material that is taken out in post-handling. MJ is one of the solitary sorts of 3D printing innovation that can make objects produced using numerous materials and with full tone. So guys, let me know your thoughts down in the comment section below. Give this video a thumbs up for more interesting content, and don't forget to subscribe to the channel for more awesome content. Have a nice day, and I will see you in the next video.